In this lesson, we're going to simplify algebraic expressions with like terms. Simplifying will have at most two steps. One of them will be the distributive property in another lesson, but this one is combining like terms. Now, like terms are terms with the same variables. For example, 3x and 4x. Those are like terms. 8x squared and negative 9x squared are like terms. 4xy to the third and 7xy to the third are like terms. We will simplify expressions with like terms by doing either the addition or the subtraction with the like terms. So let's take a look at how we will do this. Problem number 1 says simplify the expression by combining like terms, and it has 9b plus 2b. Well, those are like terms. They are both terms with b's. You will keep the b. Do not change it. Do not change its exponent in any way. Simply do the arithmetic with the numerical coefficients. In other words, you're going to take the 9 and the 2. They're both positive, so you're going to add them up and keep the sign. You're going to get 11b for that first expression. The next one, I have 9w minus 5w plus 7w. Now I should have up here underlined both of those. Okay. These are all terms with w's. So my answer will be like them. It will have a w, and I'm going to do the arithmetic with the coefficients. I have a positive 9 and a negative 5. I subtract, keep the sign of the larger for 4. 4 plus 7 gives me 11w. So you have to be able to use your addition rules for sign numbers. Next one, 4b minus 5 minus 12b minus 8. Well, in this expression, these two terms are b's, but these two terms are what we call constants. Constants because they don't have any variable part. I combine those things that are alike. So with the b's, I have a positive 4 and a negative 12. Let that sign belong to the 12. A positive and a negative, I subtract. Keeping the sign of the larger one means I get negative 8b. With the constants, I have negative 5 and negative 8. They're both negative. Add them up for negative 13. Now, these are not like terms, so I cannot combine any further. Next example, I have m minus 7m minus 3m minus 6. Well, the first three terms are like terms. The first term does not have a numerical coefficient. Well, it doesn't have one that's printed, but it has an implied positive 1. So it's 1 minus 7 would give me negative 6m, minus 3 more would give me negative 9m. This constant of negative 6 does not have any other constants to combine with, so it is just attached to the answer. So I had 1 minus 7 for negative 6. Negative 6 and negative 3 made negative 9m. The negative 6 just kind of was along for the ride. Finally, number 5, I have 7g minus 4 minus 6 minus 7g. Well, the variable terms are both g's. These are like terms, but those are opposites. From our previous language, those are additive inverses, and those combine to be 0. I have 0, but 0g. I don't have to write that because it is 0. I have a negative 4 and a negative 6 combined together to be negative 10. Okay, let's see how many more we have. We have a few more. Simplify this expression. I have negative 8h squared plus 7h squared minus 3h squared. They are all h squared terms, so that's the variable that will be in my answer. I have a negative 8 and a positive 7 gives me negative 1. Negative 1 and negative 3 gives me negative 4h squared. Next, now I'm going to do a little translating. Add 9x plus 2 to 2x minus 4. When the parentheses are preceded by what looks like nothing, it's an implied positive 1, and the parentheses can be dropped off because positive 1 is the identity for that multiplication. In other words, those parentheses were not even essential. So now combine your like terms. I have a 9x and a 2x for 11x. I have 2 and negative 4 for negative 2. That's all I can do to add those together, is combine their like terms. Now I've got to be really careful with the subtraction. This phrase is subtract 10x minus 6 from 6x minus 5. When you have the phrase subtract from, the final expression is written down first, and then the first expression is what is subtracted from it. That's very important about the order. What's in front of this parentheses? Nothing, so I can just have 6x minus 5. But when there is a negative in front of the parentheses, it's as if it's a negative 1 being distributed. That's going to make that negative 10x, and it's going to make it positive 6. You can also think of it in the subtraction rules where you keep, you change to addition, and you change the sign on every term after. I just don't put in this as a plus sign. So I've done it as distributive property with a negative 1. Now combining like terms, positive 6x, negative 10x for negative 4x, negative 5 and positive 6 gives me plus 1. You have to be very careful with that negative. I think we'll see another example like that in number 9. Subtract y plus 10 from 7y plus 6. So once again, I'm running into this expression of subtract from. So the 7y plus 6 is first, and I'll subtract from it y plus 10. The 7y plus 6 comes out. There is an implied negative 1, which I can use the distributive property. That gives me minus y and minus 10. It changes the signs of every term inside those parentheses. I have 7y minus y. That's minus 1y. That gives me 6y. I have 6 that's positive and 10 that's negative, so subtract, keeping the sign of the big one, I get negative 4. And that's our lesson on combining like terms.